Hello everyone, welcome to Explore Hop. For this example, we're told that the population of tigers in a forest was 100 in 2018. In 2020, the population grew to 120. The forest can hold a maximum of 1,000 tigers. Assuming that the population satisfies a logistic growth model, we're asked to write an equation that describes the total population of tigers in the forest in T years after 2018. So just to review, since the population satisfies a logistic growth model, then we know that it can be modeled by the following differential equation, where the derivative of P, which is the population, with respect to T is equal to R times the population P times 1 minus P over K, where K is the carrying capacity. And if we were to solve this differential equation, then we would get that the function p of t is equal to k over 1 plus c times e to the power of negative r times t. From the question, we're told that the maximum population of tigers in the forest is 1,000. So that is the carrying capacity, which is the k value. This means that p of t is equal to 1,000 over 1 plus c times e to the negative rt. And now we need to solve for c and r. From the question, we're also told that the original population in 2018 was 100. So this means that p of 0 is equal to 100, which means that 1,000 over 1 plus c times e to the power of 0 is equal to 100. So 1,000 over 1 plus c is equal to 100. And now we can solve for c. So 1,000 is equal to 100 times 1 plus c. 1,000 over 100 is equal to 1 plus c, which means that 10 equals 1 plus c. So c equals 9. And now to find r, we are going to use the other piece of information we're given, which is that the population grew to 120 in 2020, which is 2 years after 2018. This means that p of 2 is equal to 120. And we get that 1,000 over 1 plus c, which is 9, times e to the power of negative r times 2 is equal to 120. So 1,000 equals 120 times 1 plus 9 times e to the negative 2r. So 1 plus 9 times e to the negative 2r is equal to 1,000 over 120, which is equal to 25 over 3. So 9 times e to the negative 2r is equal to 25 over 3 minus 1, which gives us 22 over 3. So e to the negative 2r is equal to 22 over 27. And taking the natural logarithm on both sides, ln of e to the negative 2r is equal to ln of 22 over 27. So negative 2r equals ln of 22 over 27. So r is equal to negative 1/2 times ln of 22 over 27. Now, subbing c and r back into p of t, we get that p of t is equal to 1000 over 1 plus c, which is 9, times e to the negative r, which is 1/2, times ln of 22 over 27 t. And this gives us an equation that describes the total population of tigers in the forest t years after 2018, where the population satisfies a logistic growth model. That's it for this example. Thank you for joining us. See you in the next lesson.